Okay, so think about something like vinegar. Is vinegar an acid or a base? Acid, it's acetic acid. Okay, now think about hydrochloric acid. Okay, definitely an acid. Which one would you not want to spill accidentally on your hand?
HCl. Hydrochloric acid.
Why?
Because it's much more acidic.
How did you know that?
Because
I don't know. You just kind of know that, right? You just know that, okay, hydrochloric acid, that's really strong, right? So that's kind of the identity of an acid or a base. So like hydrochloric acid is really strong. You just know that. The way that it behaves, it really, really reacts with water to make that H3O+. But acetic acid, not so much. Okay, so it's not as strong. But what if you had a really, really, really diluted thing of hydrochloric acid and a really, 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 really concentrated solution of acetic acid? It depends, right? That really, really concentrated acetic acid might be kind of harmful if it's super concentrated. Because like the stuff that you get in the grocery store, like acetic acid's like, I think it's like 7%. That's not very much. What if it was like 99%? Maybe that would, not be awesome, right? Okay. So see how acids, it depends on those two properties, right? Because hydrochloric acid might not be so bad if it's like 0.0001 molar. But it could kill you if it's like, well, I guess burn your hand at least, maybe not kill you instantaneously. But you dumped it on your head maybe. Okay, so an acid that ionizes almost 100% in water. So think about that. It ionizes almost 100%. That means it really wants to react with water to make the H3O+. It is called a strong acid. So for example, just as Matt knew this one, HCl, aqueous, with H2O liquid, makes H3O+ aqueous and Cl-. This happens so strongly, like it's almost 100% of all the HCl in that solution will do this, okay? So 100% of the HCl aqueous becomes H3O+ and Cl-. The concentration of the H3O+ aqueous is the same. Oh, this is going to get. Is the same as the concentration of the acid it came from. Strong acids are strong electrolytes, right? Because it allows for the flow of electrons. And so if all those ions are released, that means a whole lot of electrons are able to flow. And react vigorously with metals. What does an acid produce when it reacts with a metal?
H2 gas.
Hydrogen gas, yes. So turn your data booklets to page 8 and 9. 8 and 9. Can you see it in the thing? 8 and 9, okay. So there are 6 very strong acids. Now this chart is mostly used in Chem 30, but you can use it in Chem 20, and it's for this one thing. The 6 strong acids are the 6 first ones on the list that are above that H3O+. Okay? So perchloric acid, hydroiodic acid, hydrobromic acid, hydrochloric acid, sulfuric acid, and nitric acid. These are the big 6 that ionize almost 100%. Well, pretty much 100%. Okay? Everything else, as you go down the list, decreases. Now look, what's at the bottom? What's at the very bottom of the list? Water. okay? Because it's kind of like the neutral. So once you get all the way down there, that's not very acidic, right? So as we go down, it decreases in acidity. Most acidic, so you can write this in your data booklet. 100% ionization strong acids, these 6 ones, okay? So you don't have to memorize them, you can just look in your data booklet. So if on a test or something you have to know something about strong acids, you just look in here and you can see them. You don't have to memorize them. Why memorize something if you just have access to it, right? So, these are your 6 strong acids. As I said, they are on your data booklet. That's what I meant to say. Okay, so moving on to the not 6 strong ones. A weak acid, so every other acid besides those 6 is weak. A weak acid does not ionize 100%. Does not ionize 100%. And only a small percentage of the acid forms. So only a little bit of it will become that H3O+. So only a small percentage of the acid forms ions in solution. So for example, if we have our acetic acid, our vinegar, CH3COOH aqueous, plus water, liquid, gives us H3O plus aqueous and CH3CO minus. But look here, what kind of arrows did I use? What do I call those types of arrows? I call those equilibrium arrows, because that means that not everything from here becomes this. Okay? So I need to represent that in some way, and I'm using my equilibrium arrows. So this is really important. So I would kind of circle those for you. Circle the equilibrium arrows and put a star there and say those are equilibrium arrows. Okay? You really need to kind of get that into your head what those arrows are for. Equilibrium. So we use the equilibrium arrow for weak acids, so that we can represent that not everything from the reactants becomes the products, okay, in the reaction with water. Flip your page. Weak acids are weak electrolytes. And react much less vigorously. React much less vigorously than, or with metals. Okay, so everything besides the strong acid, use the equilibrium for acids, and your strong, you can use the 1 arrow. Okay, so now bases. Now, a base that dissociates 100%, see how I use the word dissociate rather than ionize? Because a base is an ionic compound. Acids ionize. Okay? Base dissociates 100% into ions in water is called a strong base. Ionic hydroxides and metallic oxides are strong bases.